Good morning, everybody. How's everyone doing? Good? Yeah. Oh, thank you. Thank you. So, my name is Ali Alabas, and I'm a PM on the Edge team, the Microsoft Edge team. And a while back, I was trying to catch an Uber ride from my home to a venue, and my phone ran out of battery, so I wasn't able to use it on my phone like I usually would. But then I remembered that there was a mobile website that I could use that Uber had just released at that time. So I could go on over to m.uber.com and book that ride with no issue on my laptop. Now, that may sound like it may be a unique instance of that issue, but actually people have this problem every day with not having the ability to download an app because it's too big. Have you ever tried downloading a 100 megabyte application on a 2G network or where you don't have a network connection? It's pretty horrific. You don't want to try that, trust me. But this isn't a problem that's unique to us. It's a problem that we see all over the world. And if you head on over to pwastats.com, a community-driven list of stats for PWAs, you'll see that there's a ton of apps and sites that are trying to take advantage of this new wave of technology on the web and capabilities on the web so that they can build better user experiences and captivate their users. Perhaps Uber wouldn't have been able to take that cut out of my ride if I wasn't able to access the mobile site and I used a cab instead. So they succeeded in that way, and I also succeeded because I was able to use their service. And of course, there are other examples of sites and companies across a wide variety of industries that are benefiting from PWAs and their features. Of note, Grand Velas Riviera was able to increase their conversion rate by over 50% last Black Friday because of the benefits of PWAs and their performance enhancements and their re-engagement capabilities. So as you may have seen from Aaron Gustafson's talk previously, a PWA is simply these three things. HTTPS, you have your web app manifest, and service worker. If you haven't seen his talk, I encourage you to watch it. It's been posted online, so check it out. And he also mentioned that it's more than just that. PWAs are all about expanding on the already great sites that exist out there by enhancing the performance, the resilience, and the engagement of those sites and those applications. So today, that's what we're going to talk about, how to build those offline-capable, performant, and re-engaging web apps. We'll first talk about why the web platform is a first-class platform, and then we'll talk about why some old features were supplanted by new ones that help enabling those scenarios. So you may have seen a list of principles for PWAs and what they are, and this is one such list. You may have seen some others that are very similar to these. Today we're going to be focusing on two of these, the working offline and reliably under poor network conditions and being able to send push notifications. For the first one, you may notice that if you open up an application, a native application on your device, like the Windows weather application, you'll be able to see the weather and not be online. And in fact, it actually says underneath that it's been updated as of a certain time. So this is something that you get with native applications just out of the box. But on the web, if you try to do the same thing, if you try to load up an application, you're greeted with a useless web page that tells you you're not connected. And this obviously is no problem just with Microsoft Edge. You're going to get this across the board no matter which browser you use if you don't have an internet connection, or if you just don't have a great internet connection. And the second bit about being able to send push notifications, obviously, today, if you get a push notification from a native application, you can click on it and be repatriated right back into that application. And on the web, if the browser or the platform isn't running, you get nothing. You don't get those notifications. So to start, it's important to understand that at one point, there were many pieces missing in the web app model. And the first step really was to close that gap, to really bring it up to par with those native applications. So the browser vendors and other contributors took to the W3C, the World Wide Web Consortium, to create many new standards-based capabilities. And here's just a few of them that have been worked on and developed in the W3C and other standards bodies over the last decade. And so what happened really was we went from being very different from native to kind of having more in common with it so that we can have more capabilities that allowed those apps and those websites to thrive if they were on a native machine. So to understand how and why we got to where we are and the advantages of these new features, I'm going to take you back to 2012, where we were trying to do offline and we were trying to solve offline on the web. So you may have heard of this thing called application cache. And it works pretty much like this. You have an HTML file where you can define the manifest. And by the way, anyone who's following along, if you like, on the top right of these slides, there's a link where you can actually go and check out the code. And in that top HTML tag, you can define your manifest. So here we're defining the manifest, and the manifest itself will look like this. So we declare at the top that it's a cache manifest. We may have a comment there as well when it was last updated. Then under the cache heading, we're going to say all of the resources that we are interested in caching, so that if anything catches these rules, it will be served from the cache versus from the network. And then you may also define under the network heading a wildcard so that if anything doesn't get caught in those rules before, it will still go to the network, so you're not serving nothing. And then you can also define a fallback. So if you have nothing available, then you're able to still serve something. So this is what this kind of looks like. We're going to switch over here. So all these demos, if you would like to check them out, you can just go to aka.ms/swdemo, and this will load here for you. We're going to check out the first one. So this is the app cache demo. And what I'm showing you here is basically a weather application, a web-based weather application. And it's going to be giving me some ridiculous numbers here on purpose, and they're going to be randomly generated just so that you can see when it's been updated. So if I refresh this, you'll notice, okay, it actually didn't change the number, and this is because we're using app cache. But if we disconnect from the network and we try to refresh this, you'll notice that it's still loading. So we get offline, but there are some trade-offs. So Jake Archibald had some choice words about app cache. If you're interested in reading the article, there's the link for you right there. And I'm not going to reiterate all of those issues, but I'm going to go through a few of them. The first one, which you kind of saw, was that files that come from the app cache are always coming from the app cache, even when you're online. So it doesn't matter if you're online, those files, you saw that the weather didn't actually change, even though I told you it was being randomly generated and something different would show up. So the files are always coming from the app cache. You have to change the manifest file to update the app cache. So you noticed we had a comment section at the top. If you just change one thing there, then you're updating the manifest, and then the actual app cache can be refreshed and changed. If you cache the manifest file itself and you set a far future cache header, what's going to happen is you're going to have a stale site for eternity. It's never going to change. So that's a problem. And as you noticed, that list of routing and caching was statically defined. So there's no notion of dynamically caching, which is a major pitfall in this model. And above all else, it was, in essence, magical. We put in this static manifest, and the browser basically did everything else for us when it came to routing those requests. And of course, that makes it difficult to debug, because if I wanted to go in and check out what's going on, what files are being served from where, I wouldn't be able to tell, because it's not like it's JavaScript. So in essence, you get no control with app cache. So app cache is useful, but what actually happened was we learned from that experience, from having app cache in the browsers. And we learned that we have to do something about this. We have to do better. So what we have to do here is we have to actually give the control back to the web developer, something that you don't get with app cache. So let's go through what that means. So step 1 of offline ability version 2.0. We got to redefine the network requests. That's the first step. So the idea of making that first network request and every subsequent network request for all of the sub-resources. So the first concept we're going to introduce is called fetch. You may have heard about it, you may not have, but here's sort of how a regular page makes a request to a bunch of resources on the page, whatever they may be. So HTML, CSS, JavaScript, even your XML, HTTP requests, all of that stuff. You make those requests from the page, and then those pages go out to the World Wide Web. It gets it from the network, and then it gets returned to the page. With this new idea of fetch, we're redefining it. And what we're actually going to do is abstract all of those concepts into this new black box called fetch. So all those requests actually go through fetch first, and then they're going to go to the network. So step 2 of this, and sort of a side effect of fetch, is that we can expose these concepts to JavaScript. So the idea of being able to fetch the actual request and the response primitives as well. They can be exposed to JavaScript. So here's what that looks like. So if we're fetching the weather.json that we want, we would just call fetch, and then we would pass in the link for that. And then we would use .then, which is basically because it's a promise. If you've never seen a promise before, just know that it's a way to do asynchronous handling. And we're using .then to say once that action is completed, we're going to do this after. So after the fetch is completed, we're going to then get the response from it. And then from there, because remember, the response is now a primitive we're exposing to JavaScript, we can get the headers. And we can specifically get the content type and check if it includes JSON, for instance. And if it does, we can use this helper method, .json, response.json, and then get the actual JSON information from that object. And if it's not, we can obviously throw an error. Here's what this looks like if you were to do it with XML HTTP request. So it's a lot lengthier. It doesn't look as nice. And quite frankly, it's a little less robust because you don't get all of the data that you were getting with the response objects, for instance. So the next step, step 3 for offline ability version 2, we need to provide a way to intercept those network requests. So again, we're requesting all those sub-resource requests. We're going through fetch. The next natural step from here is to actually go through something you guys all know and probably love, JavaScript. Give you guys an opportunity, the web developer, to go through a JavaScript worker that can then intercept these network requests. So this brings us to this brand new thing called service workers. If you've never heard of it, I'm going to tell you about it. So on a normal web page, obviously you get things from the network, and then it gets right back to the page. In the world of service workers, instead, you're actually going through the service worker, and then it's being returned back to the page. And this opens up a whole new world of possibilities of being able to offer offline ability, but also to offer the ability to give you better experiences when you have flaky network support, for instance. So you're probably wondering, this is all well and good. Is this available on all the browsers? Can I use it across the different browsers out there? And the answer is yes. The service worker is available across Chrome, Firefox, Edge, Safari. So you're able to use this feature as of today. And it's even available if you, as Aaron said, if you write a Windows 10 application, a PWA, you can use it there too. So this is how you would use it. The first thing you're going to do is you're going to call navigator.serviceworker.register. You're going to commit that to memory. And this, you have to know, will only be possible if you're in a secure context. So if you're using HTTPS, you have to be using HTTPS to use this feature, because it would be weird if you were non-secure and then you had a service worker installed and you could get man-in-the-middle. It's a big problem. The next step is you're going to provide the service worker file. It's just a JavaScript file. We're calling it here sw.js. And this script can't be on a content distribution network. Again, for security reasons, that script itself has to be on the server that you're serving it from. It has to be local. The scope as well is then defined. This scope is going to tell the service worker which pages it's going to control, which pages that it will actually intercept the requests for. So in this case, we're just telling it the root document, but you can tell it any other URL pattern. So I could do /myapp, for instance, or whatever else, whatever other page I want. And it's important to note that the mapping between a scope and a service worker is 1-to-1. So if you try to register on the same scope again, it's actually going to update that service worker. It's not going to have two service workers. It's going to try to update that service worker. So at this point, when the service worker is registered, again, we're using .then here because it's promise-based. If you have app cache, so if you're trying to do a progressive enhancement where you use app cache where it's not there and you're trying to use service workers when it is available, you're actually going to trump app cache in the sense that service workers takes precedence over app cache. And in this case, we can do something when the service worker is registered, and if it's not, then we can surface an error potentially. Or it can just silently fail because, again, service workers are progressive enhancement. So the first thing to note in the service worker is that it executes in a separate context from the page. So here we're in the service worker, the sw.js, and it's also important to note in the service worker, you don't have access to the DOM because it's executing in a separate context. So the document object model is a concept that is in the page, your web page, and because this is executing separately, it's not going to have a DOM. So it's event-driven, so one of the first things we can do in a service worker itself is handle the fetch events. So we can do self.onFetch. We can also do add event listener for fetch as well. It's up to you how you want to do this. And if you are familiar with arrow functions, you're able to use that here as well. I'm just making it simpler so that those who haven't used arrow functions before are able to follow along as well. So once that fetch event has come through, we can handle it, and this event handler will run. And in this case, we can use the respond with method, which will allow us to pass in either a promise that gives back a response object, or we can pass in a response object itself. In this case, we're going to pass in the fetch method. This is going to respond back to the page for any of the fetches that happen on the page with a fetch that goes out. So it's basically doing a pass-through. And we're just telling it to do event.request here. It's important to note that only asynchronous requests are allowed here. So you can't be using synchronous XHR, for instance. So we're going to look at how that looks like. So when we look at this page, I'm going to turn on Wi-Fi again. Okay, we're connected. We're going to refresh this. And lo and behold, it's working. I'm going to refresh it again to kind of show you what I meant before when it's giving me a random number. So we went from 41 to 87. We're going to try that again just so you guys get a sense of how this works. OK, so now I'm going to disconnect from the network again to see what happens. What happened there? Well, like I said, what we actually did was nothing useful. We just did what the browser did to begin with. We just did a pass-through, right? So you're probably wondering, did I just waste all your time? Well, hang on. Give me a second. I'll explain. The next step of offline ability version 2 is providing a way to save those responses. We need to be able to save those responses to do anything useful. We need to be able to cache them. And that's where these new cache APIs come in. So instead of going just to the service worker and coming back from the network, what we're actually going to do is we're going to go to the caches and then return back to the page via the service worker. And these caches have some important properties that I'm going to go over briefly. So it's a key value pairing that gets stored in the browser on the platform of your client. So it's client-side storage. And it's going to be the key is going to be the request, so the URL of the request, and the value is going to be the response, so the actual data of the response. Every different domain is going to have their own allotment of caches, so you can't be dipping into other caches from different domains. And every domain can manage multiple caches, and the way that you differentiate between the caches is they're going to have different names. So you're going to assign them different names. So now that we can save responses with this new cache API, the next step is to define the service worker lifecycle, being able to install them and control pages and update them, and also being able to remove them when they're no longer needed. So defining that lifecycle, that framework by which we can update everything. So the first step of that would be to provide that installation. So again, this is event-driven. So the first thing here we're going to do is self.onInstall, where it's going to initiate the installation of the service worker. And here we're going to use a new method called waitUntil. What this is going to do is it's going to take a promise so that when the promise is finished, it will then complete the installation. If the promise never resolves and the service worker times out, then we abandon the registration of the service worker. So this is a great place to prime your caches in the registration. So that's exactly what we're going to do. We're going to use caches.open. And again, we're going to name the cache what we want to call it. We're going to call it assets version 1, for instance. And then when we've opened those caches, it's asynchronous. All of these APIs are asynchronous. They're using promises. We're going to use the add-all method to simplify the process, of which we're going to say all of these resources we want to cache. So this is going to take all these resources and put them into the cache so that we can use them later. So we're going to see what that looks like now that we have started caching things. So if we open up F12, you'll notice first thing is that the F12 console is going to tell you that you're using service workers. So it lets you know. And this is important to note because any network traffic that happens in the service worker is actually going to happen in the debugger that is attached to the service worker itself. And I'm going to show you what that looks like. But keep this in mind. So if you see this, that's what that means. It's also a good indicator that you know that this page is using a service worker. What we're going to look at first is this new storage section. So FYI, I'm running the latest insider build of Windows, which will be the public release coming up very soon. So all these things are pretty brand new in the sense that we've now pulled away the storage tab and the service workers tab over here. So what we're looking at here is under storage, there's a cache section. And under the cache section, we see the assets v1, and we can see the resources, the key value pairing of the things we just said we primed to the cache. At the same time, we can hop on over to the service workers tab and see the service workers we have installed. These are all the service workers I have installed for the demos that I'm going to show. But here's the one for this one specifically. I can actually go and inspect it by clicking on the inspect link over here. And that's going to open up the service worker that I can then inspect over here. Probably going to have to refresh this. So as a reminder, service workers have a lifetime, so they can be terminated at any time, in which case you just have to be aware of that. So there's the service worker, and we can see that it's doing this pass-through that we described earlier. So the first step, as we saw, was installing the service worker. That's where we installed it and got everything set up as we liked it. And as part of that installing step, we actually send the event for the onInstall in the service worker so that it can do the installation. The next step is that it's installed. This is where the setup is complete, and we're waiting for clients to be closed. So what are clients? Clients are windows, iframes, anything that can be controlled by a service worker. So as a reminder, a service worker that's controlling a page is basically a service worker that's going to be able to intercept the network request for that page. So the reason why this is important is because you don't want to have a service worker installed before it's able to kind of shut down working on the page that it's working on. Because then you're in this state where you have a new service worker that's doing stuff that's for a page that didn't expect that new service worker to be there. So to gracefully deal with this, all of those pages, for instance, have to be first closed, as one example. There are ways to force this to happen via JavaScript, but in essence, you have to wait for those pages to close. After that, once no clients are controlled, we then go to the activating step. This is where we take an opportunity to clean up other workers. So if we're doing an update, this is a great opportunity to clean up those workers that we had before. And that's what we're going to do here. So as part of the onActivate event that gets sent up through the activating phase of the service worker, we're going to first maintain a list of things we'd like to keep. So if we have a list of assets that we think are still relevant in the new service worker, we should keep those around so that we're not being wasteful about recaching things. So what we're going to do, again, is wait until, because we want all of this stuff to complete before this event finishes. We're going to get all the keys from the caches. Remember, there's a different name for each of the caches on the domain, and we're going to get a cache name list. With that cache name list, we are going to wait for all of these caches. We're going to go through each of the caches, each one of the different named caches, and we're going to check if the caches are in the list that we had at the top, the keep list. If they are, then we're not going to do anything. If they aren't, we're going to go ahead and delete them. Because the things we want to keep, we're going to keep. The things we're not, we're going to get rid of. So at this point, the service worker is now activated, and it can fulfill its destiny. It can now handle those fetch events. So at this point, you can do something like the self-onFetch. So up until this point, you're kind of just setting everything up so that things can start doing this awesome behavior of being able to fetch. So here what we're going to do is we're going to improve upon the example before. We're not just going to do a pass-through. We're going to use the caches. So how we're going to do that is we're going to first use caches.match. And that's going to give us a match for the request that we just got from the page. If we have it, we're going to return it back to the page. But if not, we're going to gracefully fall back and go to the network and try to fetch it. And if that fails, using catch, which means the promise didn't resolve, so the fetch promise failed, we're going to go and see if there's a match for the fallback that we had. And if you remember, this was primed in the cache as part of the installation, so we know that it's there. So if all else fails, we have something that we can depend on. So to recap, the first thing we did was install. That's where everything gets set up. And then we went from the installing phase to the installed phase, where once everything has been set up, so that's when the installation step has finished. And then we went to the activating phase when the onActivate event gets fired in the service worker. And then we went to activated, where it can finally handle those fetch events, where it can fulfill its destiny as a service worker. But at the end, if you were replacing it, as you recall, if we do a register on the same service worker file for the same scope, we will then become redundant in the sense that we're going to replace that service worker. There's other ways you can update it as well. By policy, the browser or the platform itself will try to update as often as possible when events are running, so that you're always getting the freshest possible. So we're going to switch over now that we have that better example of a service worker where it actually caches. And we're going to look at what that looks like. So here we go. We're getting different numbers here. We're going to go offline and see what happens now. Okay, so we're getting the fallback, which is not bad. Now, this kind of is not much better than what we got with app cache. And the reason why is because we basically just did a fallback, which is something we could have done before. So what we actually want to do is something that's now possible with service workers that you didn't get with app cache. And it's being able to cache dynamically. So whenever we get that new weather data, we want to be able to update the caches to have that new weather data. So how we're going to do that is quite simple, in fact. If you recall that cache statement that we had before, we're just going to swap that out and be a little more robust, where we're going to do some dynamic caching. So here what we're going to do is we're going to open up a new cache and call it dynamic. And in that cache, we are going to use cache.put for the event request that we just got and put in the response that we just received from the fetch that we did. So if you recall, if we don't have a response, we're going to go ahead and fetch it. And once we fetched it, now we do have the data, and we're going to put it into the cache. And we still want to return that response back to the page. So we're going to clone that response and give it back to the page. The reason why we're cloning is because when we put it into the cache, we've consumed the stream. So we have to clone it, and that will help us return it back to the page. So now we can take a look at what it looks like when we do that. So here's an example of the page working while we're offline. So you can tell here we're offline. And we're going to go back online to see what that looks like. Give it a sec. There it is. Hey, look at that. We're right back to where we started with app cache. So we're not quite done. So dynamic caching we didn't fully realize the benefits of dynamic caching just yet. So we could do better than this. And that's what we're going to do. So we're gonna hop on over and check out another demo where we actually do some dynamic caching, and we're going to see what that looks like. So you'll notice that now we're showing content when we're online, that's fresh. So it's updating. And then when we go offline, we have a graceful fallback so that we're showing something. Even though it's stale data, it's still a better experience than having nothing at all. So how do we do that? We're going to have two paths depending on the request. So the first path is we're going to check if we're looking for the weather.json file. So if that's the request for weather.json, we're going to respond with the fetch and cache. And if you recall, that's what we were doing before. I just abstracted it away here as fetch and cache. We're again just fetching, and then once we have the response from the fetch, we're going to then put it into the dynamic cache and then respond with the clone. If it's not the weather.json, we're going to respond with the caches.match, and then we're going to respond with that, and then do a fetch and cache if we don't have that as a fallback. At the same time, on the page itself, so that was the service worker. Now we're back to the page, index.html. We're going to fire the event for weather.json. And once we have the response back from that, we're going to get the JSON information from it. And then from that, we're going to update the page with the JSON information we just received. If that fails, we're going to check if there's anything in cache for weather.json. So this is how we're dealing with that graceful fallback that we saw. And once we have that, we can respond. We can get the JSON from the response and then update the page from that JSON response. And if all else fails, we really have nothing, and we can do something like show a please connect and try again kind of page, for instance. But we can do even better than that. So here's really what we want to do. Ideally, when you're connected, what we want to do is show the stale data first from cache. As you noticed, there's a bit of delay when I'm loading these pages because, the Wi-Fi. And what we want to do is show the stale data as soon as we can so that we have some experience right away, and then show the fresh content when it's there. And of course, when we're offline, still be able to show the data that we had from before. So there's me refreshing it. So this is the ideal user experience, because this way, we load something right away when we're online. We load something right away when we're online, and then when we have something from the network, when it responds back, we're able to show something. So this is something that allows us to really give you a better user experience with this feature. So to explain how you would go about doing this, I want to tell you a short story. When I was younger, I had a teacher that liked to give us puzzles, and he would try to tell us to do weird things that were really impossible or seemed impossible at first to manage to do. So he asked us, how do you draw this box with an X in the middle without lifting your pen and without going over the same line twice? So attempt after attempt, it seemed like it was pretty impossible. You would always kind of miss one edge, right? Does anyone want to try this? Anyone interested? No? This is better handled when you think outside the box, or maybe inside the box, I'm not sure. What you actually want to do is go at it from 2 points. So start with 2 pens, perhaps, and go and draw it out. So like you just saw there, let me show you that again. So 2 points, and then going through the center, and then around. So you want to simultaneously do this. And that's what we're doing here. What we're going to do is we're going to get from the network and the cache simultaneously. The first thing we're going to do is we're going to set a variable that's going to tell us if the network is done, getting from the network. In this case, we're going to instantiate it to false because we haven't got anything yet. We're going to make that network request to weather.json, and then we're going to get the JSON back from it. And we're then, because the network is finished, we've retrieved the information from the network, we're going to set that to true, and we're going to update the page with the JSON. At this point, we're also, at the same time, going to check the caches to see if this exists there as well. If it is, we're going to get the JSON back, and then we're going to check if the network is done, because obviously, if the network isn't done, we don't want to show the online fresh stuff first and then swap it out with the cache stuff, because that would be a really weird and jarring experience. You always want the network to win if you have fresh data. So if the network is not done, we're going to update the page with the cache stuff, and that's why we got that really instantaneous feedback from the cache, and we're able to see the cache stale data first while we were still waiting for the network. And if we don't have anything in the cache, and that's okay, we just fall back to the network. So this is another graceful way to handle that fallback. And if that fails as well, so if we can't even reach the network, then we have nothing, and we can do something graceful there as well, like show that you need to connect to the internet, for instance. So at this point, we're going to look back at the list for those gotchas of app cache. So if you recall, the files from the app cache are being served from there even when you're online. In this case, the caches are only used when you say so. You must change the manifest to update. The service workers are updated frequently, and the browser and the platform will make sure of that. The manifest file will make the site stale. If you remember, if we do a far future cache header, that will cause your site to be eternally stale. Just, again, the browser and the platform is going to make sure that those are going to get updated. If you recall, this was all statically defined in app cache, but here, everything is programmatic, and you can do dynamic caching as well. So it's no longer the case that you can't do dynamic caching. And if you recall, it was also magical and difficult to debug. In this case, you have JavaScript that you can go and set breakpoints with, and you can step through the code and see what's happening so that you can debug it. So can we do better? Yes, we can. We can build a full-scale web app that loads even when you're offline. And here I have with me Matt Rowe from the Office PWA team that will be telling you all about what they've been doing in terms of their PWA.
Thanks, Ollie. Good morning. So my name is Matt Rowe, and I'm a program manager on the Office.com team. And one of the things that we've been doing recently is working to deliver Office.com as a PWA on Windows 10. There's a couple reasons that I'll get into in a second for why we're trying to do that. But I'd also like to talk to you about how we're using service workers both on Office.com and in our PWA to make this experience, to kind of enrich this experience. So this is a picture here of our PWA, and you can see that we have a number of different elements that go on the page. The first thing we have is a set of applications, links to applications. We have a set of recommended documents, and we also show the most recently used documents list. And we show applications and documents across first and third-party sources. So as you can imagine, this page requires a lot of calls. There's a lot of network calls to generate this. We actually show the header as well, which is another set of calls. And so performance is very important to us. And we've been using Service Worker to facilitate better performance and also some other scenarios that I'll talk about here when we get into the demo in a little bit. So on the Office.com team, we talk about what are kind of some of our key goals. And one key goal is making sure that we use the phrase freaky fast. And the reason is because there's a lot of research that shows that if there's even a second of delay in page render time can cause a significant drop-off in referral rate or success, whatever the particular success criteria looks like there. And so being freaky fast is very important for us in terms of making sure that users can get where they're going quickly and efficiently. And also, as we've been delivering this experience as an inbox app on Windows 10, we now need to support scenarios like offline and loading in a way that's kind of more app-like. And so we've been using Service Worker to do both of those things. And so rather than talking about it, I'm going to jump over to a demo. And I got to log in. Okay, so this is an example, and I'm going to go ahead and kick this off so you can watch it load while I'm talking. So on the left-hand side here, I have the Service Worker empowered page, and on the right-hand side, I have a page that does not have Service Worker active, and this is Office.com. And so I'm going to give the slow page a little bit of a head start here, and it's actually rendering pretty quickly, which is kind of a bummer. So I wasn't supposed to show the speed of Service Worker. So I'll kick off another render here. So you can see that we're rendering the elements in the page on the side that the side that's empowered by Service Worker very quickly, and we come back with the recommended documents and the most recently used documents list very quickly, and we're actually able to render in the images for the recommended documents, which are also part of the request, very quickly, and the page comes back much quicker than when we're not using Service Worker. Now, we haven't flighted this out externally at 100% yet, so you may not necessarily see this if you go to Office.com, but we're seeing significant benefits in using Service Worker here in terms of performance. But that's not the only thing we use Service Worker for. We also use it for our Office PWA. And so I'm going to open the Office PWA, and again, you can see I'm loading this page relatively quickly. I'm online, so I get my current content. I'm able to scroll down and see all the elements of the experience here. But there are certain times when I may not necessarily have an internet connection. I would say that it might be when you're on an airplane, but increasingly that doesn't seem to be a place without internet anymore. So, but let's say that I'm on a spotty network connection, or I'm in a place where there just isn't internet available, and I still want to get back to the work that I'm doing. And that's one of the things that we're trying to kind of create is this experience that helps users get back to their work. And if you're working offline, I want to be able to do that. So I'm going to open up the PWA, and of course, as we've seen in the previous demos, it still renders. I get all of my assets. I can see I have access to my applications. These tiles, instead of launching the web versions because I'm on the desktop, will launch the desktop versions, which I still have access to. And I'm actually even able to continue loading files, even files that came from the network, if I've already loaded them, which if they're in my most recently used documents list, that's going to happen. So in this case, I'm loading this Q3 sales and marketing report. This is a network file from SharePoint that's loading because it's in the Office Documents cache, so I'm still able to get back to the work that I need to do even when I'm offline, thanks to the power of Service Worker. So you might say, okay, so those are interesting demos, but what about real world impact? And so let me switch back over to the deck here. So let's take a look at some of our product telemetry. So this is an example of the document most recently used list render time, and this is perceived time. So this doesn't just capture the network call, this captures the time from we initiate the network call to the network call actually renders on the page. And as you can see here, we've got the time in milliseconds on the y-axis, and then the x-axis is workday, so we don't have a lot of variation over the course of the day. It's not a volume issue here. But our calls that are not powered by Service Worker take about 2 seconds to complete. Our calls that are powered by Service Worker, we have that down to around 1 second. So we almost render that page in 1 second, which is kind of a standard for us. So that's great performance, but let's look at a more expensive call. So this is the SharePoint Sites SharePoint Sites module render time. So you may have seen at the bottom of the Office.com experience, we have a module that renders your frequently used SharePoint sites. So in this case, we're actually able to get an even bigger gain. The call is more expensive. It comes back in 4 to 5 seconds, or actually, I'm sorry, 3 to 4 seconds. And we actually save about 3 seconds on that call, again, getting it down to close to 1 second, which is where we're targeting and where we want to be. But service workers are more than just about performance and offline. They also support other scenarios. They're really an app model that enables these event-driven JavaScript functions that can run independent of the web page. And so there's things that we might want to do that go beyond just caching data. For example, something we're considering in the Office.com context is notifications. And notifications are important for us for a couple reasons. We're obviously trying to help users figure out what has changed in their set of work, and so we might send notifications for activity, or we might send notifications for new recommended documents. And then there's also kind of a generic Office notification framework that we would integrate with as well. And Service Worker would enable us to push those notifications to the device in a way that is consistent with what happens in the native OS. And so I'm going to hand it back to Ollie, who will be able to talk a little bit more about how you can accomplish that.
Thanks, Matt. So we've been talking about service workers and the events that they have. So we have the lifetime events, which are the installation and the activation. And we've been looking at one type of functional event, something that allows a service worker to run and do something, the fetch event. And that helps us solve the working offline and reliably under poor network conditions. We're going to shift over and talk about sending push notifications on the web. So push and notifications. So I'm going to show you a quick demo of what it looks like to do a push notification. So we're going to go over to our push example over here. Again, aka.ms/SW demo. The first thing you're going to see is that I'm getting a request to show notifications. Because we're on the web, this is going to be a request that you get. Obviously, push notifications aren't going to just go run a wild everywhere. I'm going to say yes, and then when that notification prompt has been dismissed, if I load this page now, I will start seeing notifications on the bottom right. It's also cool that these notifications will get stashed away here so that you can then click on them later. So at the same time, we've also created a tutorial demo that you can check out at aka.ms/webpush. And you'll be able to check this out and see the actual code as well by going to GitHub. So you can go over to GitHub and actually clone the repo. And we have all the instructions down here of how to set it up on VS Code so that you can run this demo as well. The demo is basically a tutorial itself, but it will also show notifications. So it's a astronomy-themed demo, so you can check it out and let us know what you think. So in terms of how you actually do this, how you set up the push notifications, we've been talking about the page and the service worker, and it all starts with there. The first thing you're going to do is you're going to register the service worker. And now there's a separate component, which is the cloud. This is where you're going to be doing those pushes, where you're going to be sending those push notifications. So what you're going to do first is on your application's server, so this is a server you maintain, you're going to get what's called a public key. And I'll talk a little bit more about what that is. Once you get that, you are then able to subscribe to a push. And that will involve using a notification service that's managed by one of the companies. So for Microsoft Edge and for Windows, we're talking about WNS, Windows Notification Service. And if you're using Chrome, it's going to be FCM. If it's Firefox, MCS. So once you get that subscription from the push notification service, you're then able to save the subscription data to your application server for later. And then at some other point in time, like something gets updated, for instance, on your server, and you want to send a push out to a client, what you do is you retrieve the subscription data from your database on your application server, and then you notify the push notification service. So again, in Windows' case, it's going to be the WNS. So from there, WNS will notify the client's service worker, and it will wake it up so that it can then show a notification. And when that notification is clicked, you can then show a page. So that's sort of the life cycle of a push notification. So to do this, you're going to need several handful of files that we're going to go through, and we're going to talk about how to set this up. The first thing is the actual main page itself. This is what's going to register the service worker, and it's going to create that push subscription. There's a service worker itself, and it's going to be handling two new events, the push event and the notification click event, so that it can show that page. We're going to have a Node.js server that we're going to build here, but you can use any server that you like. And this is just going to be the logic of the server, and it's going to route the requests that are coming in. We're also going to have a database as well. And here we're going to, in the example we're going to connect to MongoDB, but you could use whatever database you feel is best. And then it's going to create the object schema as well. And finally, we have a file that is going to manage notifying the client. And in this case, we're going to just set up a file that's going to be attached to some scheduled job that gets run every day at some defined point in time. So on the client side, we have the service worker, which is going to handle the push and notification click events. We have the push API, which we're going to use, which is going to help us subscribe for those push messages. And we have the notification API, which we're going to use to show and hide those notifications. So these are the new capabilities that we're going to be taking advantage of to make this possible. On the server side, we're going to be taking advantage of two new policies and specs that are going to help us. The voluntary application server identification, which is acronymized to VAPID, and message encryption. So both of these, we're going to be using a web push library to help us abstract them away. You can get into the details of them, but it's really not necessary to set this up. So the first thing we're going to do is we're going to set up our server side. And I'm not going to go into this in too much detail. Just know that we're using a Node.js server here, and we're listening to some ports. In this case, we're listening to port 4000. So if we were using VS Code and we open this up, we can start up our server, and you'll see that it's starting to listen for port 4000. At this point, we're going to set up the server side, and we're going to set up the VAPID details. So the first thing we're going to do is we're going to require web push, and that's the library I was talking about. So we're going to import that into our server. The next thing we're going to do is we're going to instantiate it by setting those voluntary application identification details. Now, hopefully this isn't super overwhelming, but all you need to know is you need to supply an email address so that if something goes wrong on the application or on the notification service, they have some email that they can reach you at so that they can let you know, hey, we're seeing a lot of drop-offs, for instance. And then you got to also provide a public key and a private key that you will use. The public key is something that you're going to provide, again, to the page. The private key you're going to keep on your server. You're going to keep that secret. For both of those, you don't have to create these yourselves. You can just use a helper method in the web push library, which is generate VAPID keys, and you only need to do this once. Once you've generated those keys, you can then reuse them as often as you like. They will be valid for the rest of the time. So in the database, this is going to be how you set this up. This is mostly boilerplate, so I'm just going to narrow in on the part that matters because you can set this up however you like. You have the schema. So the first part of the schema is the endpoint URL. This is going to be the notification services URL that will provide to you that you will need to message to let it know to send a message back to the client. And you're going to have the encryption material as well. So this is going to be used to encrypt the payload that you will be sending to the user. The reason why this is important is because the notification services like WNS or FCM for Google or MCS for Mozilla is so that they can't actually look at what the payload is. So that data will be encrypted. They won't know what it is. They're just going to be shuttling that information along to the client. And then we're also going to keep track of when the database record was actually created if we want to run some kind of job that clears out anything that's old, for instance. So using Robo3T, which is a way to introspect the database for RoboMongo, we can see the actual data that's being, the content of the database itself. So here's a sample of such data. You'll notice under the endpoint, we have an actual URL to notify.windows.com. It'll be a different URL for the Google service and for the Mozilla service as well. So going through the steps again, the first thing we're going to do is register that service worker. And you guys already know how this is done. You guys should all be pros by now. So we're going to register the service worker, sw.js. And then we're going to be listening to a new promise. It's the ready promise. This is a promise that will tell us when the service worker is ready to start handling push subscriptions so that it can set up a push subscription. Here, we're going to get the registration of the service worker, and we're going to get its push manager. That push manager will allow us to get the subscription. Now, if we have a subscription already, this is the first thing we want to do. We just want to return that subscription. There's no need to resubscribe if we already have a subscription. So we're going to short circuit and return that subscription. Now, if you want to be more advanced, you'll also maybe check as a best practice that if the expiration time is within 5 days out, you want to renew the subscription in case we don't get another chance to do that. Otherwise, it's okay to use the subscription as is. To resubscribe, we first need to unsubscribe and then subscribe. So every service worker can only have one subscription that's alive at one time. So at this point, we are then going to get the public key. So we're going to get that public key from our server. If you remember, when we generated those Vapid keys, there was a public key in those two, and that's the thing we're going to get. So we're just going to do get public key, which I've abstracted away to essentially doing a fetch to some endpoint on our server, and that will get us back the JSON that we're interested in looking. So it does a fetch to API/key, and then we get the JSON from there, and then we're going to do our URL base64 to uint8 array to enable this to work on Chrome. So it won't take this just by itself. You'll have to do the conversion first so that it can take it. It will work in Edge if you don't do this, but if you want to make it cross-platform, just make sure you do that. So at this point, on the actual server itself, to show you what it looks like, all you're really doing is just giving back, we're sending back the Vapid public key. That's all it is. There's nothing special about what the get public key on the server side looks like. So at this point, we're going to subscribe to the push. As you recall, doesn't matter what service you're using. This is a standards-based API, so it's going to figure out which one to use. And it will give you back the correct endpoint URL that you will then be using to message. So here we're going to get the registration, and we're going to get the push manager, and then we're going to call subscribe. We're going to provide the user visible only flag, which means that for this subscription, we are only going to be using it for showing notifications. This is important because, as you might be aware, there are ways, if you don't do this, you can just keep pushing to a client and then do something malicious, maybe like Bitcoin mining on the machine. And you could just take up CPU cycles all across different clients. So I hate to break it to you, but you won't be able to do that here. This is a contract you will be setting up by saying user visible only true. And then you will also set the application server key. As you recall, that application server key is the public key we just got back. So that's what we're piping through to that. And that will then allow us to, at this point, when the subscribe is called, we get a permission prompt in a browser. So whether you're using Chrome or Edge, you'll get a permission prompt that's going to ask you if, as the end user, if you want to get notifications. So to kind of demystify some of the magic here, all this is doing, the subscription, is it's making an HTTP request to that server, to that notification service, and it's asking for a subscription to be made with the information that's provided. So now we're on. Now we got to save the subscription data to the cloud, to our applications server. How we're going to do that is once that subscription is done, once the subscription has finished, we're just going to save that subscription. We're going to pass in the subscription we just received. And save subscription is just simple. We're just going to do a fetch to some API endpoint, which will then take care of taking their subscription that we just received and passing it over to the server so that it could save it in its local database for use for later. And so on the server itself, the way we handle that is we're just checking. So if the URL is API/subscribe, we're just going to create a new subscription object, and then we're going to go ahead and save that to our database. Again, this is Node.js. So you can use whatever server you want. And then we're just going to let the page know that the response was OK. We're all set. So again, using Robo3T, we can look at the information as people start subscribing to this website, and we can see all of this information. We can see what the keys are. We can see what the endpoint URLs are. We can see when they've been created. So as they start populating, they'll all be here, and they'll be ready for us to use when we need to start sending notifications to those clients. That brings us to the next step. We need to retrieve that subscription data so that we can then send it. So retrieving it, again, this is boilerplate. I don't want to jump into it too much, but basically, we're just going to iterate through each one of those database entries, and then we're going to, as we go through each one of them, we're going to notify the push service. So the way that works is we're going to use the web push library, and use send notification, provide the subscription data we just received from the database, and then provide a message that we want to send. And again, to demystify this, it's just going to be an HTTP request that happens from your application service to the notification service. But in this case, we're abstracting it away through the web push library, which takes care of the things like encryption for us. At this point, if we don't succeed in sending that notification, so if we get back, for instance, a 410 error HTTP code, that means that the subscription is no longer active. We weren't able to reach the client. So we may want to actually remove the information from our database so that we don't keep trying to send data to that client. It would be wasteful for us to do that. So at this point, you can actually emulate the push event in the service worker by using push inside of the F12 tools that we saw before. So if you recall, there's inspect there, but there's also a push tool as well that you can emulate those events. So that brings us to this part where we notify the client's service worker, and the service worker is now woken up, and it can then handle the push event. So we're going to use onPush, self.onPush, and we're going to get the payload information. So that's the information we just got from the application server that told us what information to show in the notification. So we're going to get the text from that. And at this point, we want to show a notification. Remember that contract we set up with user visible only? You got to show a notification. So we're going to wait until and pass in a promise, registration.showNotification. Here we're going to give it a title. So weather advisory, for instance. We're going to give it a body, which is the payload we just received from our application server. And we're also going to give it an icon. And for bonus points, if you want, you can also set actions, which are going to give us buttons. This is new in the latest release of the Insider release in Edge. And what that will look like is a notification that gives you some buttons that you can do something else with. And I'll show you how to handle those different buttons first in a bit. But first, we're going to try something out. So you guys are going to pull open your phones, and you're going to message me. Sorry, this is So I'm going to give you guys a couple of minutes to capture that. If you guys really want to annoy me, you just refresh that page. So I'm going to switch over to my machine so you can see that we have a really annoying crowd here. So they're just going to keep coming in. Thanks, guys. So now how do I stop getting annoyed? I'm going to go into here, and I'm going to clear the permission. So there's a few ways that I can do this. I can either turn off the permission, I can clear the permission to reset it. So I'm going to go ahead and do that so you guys can stop this. And of course, these notifications, now that they're showing up, I can click on them, and then it will get me back to this page. Of course, if I close the page first, it'll be more interesting. So let me do that. Oh, it looks like I cleared the notifications. Does someone want to? Oh, we also cleared the permission. So it's working as expected. It's all good. So the way that worked is we just basically sent that page. What it's doing is it's doing a call to the application server to tell it to send a notification to the notification service, which then sends me a notification on my machine, which is already subscribed to that page. So once we've done that, we can show the page. And the way that we do that is we handle the notification click event. So the notification click event is another event on the service worker that we can handle. And the way we do that is we first dismiss the notification. So once it's been clicked, we're going to close it out. And remember how I said you can handle those different buttons? This is your chance to do that. You can check what the action, if there was an action that happened on the notification. If it was a smile or a frown, we can do something with that. Again, that's new in the latest version. That's going to be going out. And then at this point, we're going to wait until we're going to get all the clients and see only the clients that are Windows, and we're going to include the uncontrolled clients. If you remember, service workers can control clients, but they can also not control a client. So if it's a client that's on the same domain that you have, you can still get those clients from the service worker. And the reason why this is important is because I want to figure out once this notification has been clicked, which window to either refocus if there's already one open to that page, or if there isn't one, I want to open a window for that page. So the way to do that is I'm going to iterate through those pages, through those clients, and then I'm going to focus something. If I want to be more robust, I will actually try to figure out which one makes the most sense to focus. But that's something that will require you to figure out if there's a page that they're engaged with, for instance, or if they're on a message, for Twitter, for instance, and you just clicked on notification for receiving a message, maybe you want to focus that one. You can do something a little more robust there. And then if you don't have anything, you can fall back to opening up a window, opening up a client, and that's fine too. So in that point, you open up your app, and you're back to where you started. You repatriate your user. You re-engage that user back to your page. So this is also something new that we've also done for the latest version. We're now handling the on-push subscription change event, sorry. And this will happen when you're within the last 5 days of your subscription expiration time. And so for this, again, you're going to listen to the event. And we're going to wait for until both of these promises that follow to finish. That's what promise that all does. And the first promise will check if the old subscription is specified. If it is, let the server know to delete it. Otherwise, just resolve the promise. Okay? And the second promise, if a new subscription is specified, we're going to resolve with just that. We're going to return that. Otherwise, we're going to subscribe to a new push. And then we're going to save the subscription to the server so that it can have the updated subscription so that we can send a notification after. So these are the types of events we've seen so far with push, notification, click. But you can imagine that because this is a web app model that now enables other events to happen that are outside of the context of the page, there are other events like background sync that you may have heard about in Aaron Gustafson's talk earlier, which we can now enable with this new model. And those are things that we're looking at in the future. But you can just imagine that this makes it so much more robust and so much more capable for the web. And I'd like to end on a note. I was trying to talk to customer support with Comcast over the weekend, and I noticed that usually the fastest way to deal with this is to go online and just kind of tell them what you need. But then I noticed also that when you start talking to them, they want to put you on hold right away, and that's a little inconvenient because how do you know when to check back your window? Have you guys ever done this? I mean, you kind of have the window open on the side, and you're like waiting for them to respond, but you're also trying to get some other work done. It doesn't really work out super well. Something that they can do is maybe show some push notifications so that you can minimize the window, for instance, and then start getting notifications. Hey, you know, we're responding back, for instance. Something else they may be able to do is use those background sync capabilities in the future to also be able to send messages when you are on a flaky network and when the network drops off, and then you come back on the network again, which is something that these messaging applications have been able to do on native, but not on the web so much. So to recap, we talked about why the web platform is a first-class platform, and it's going to continue to grow. And we talked about these new features that enable these key new scenarios. So I encourage you to try these features out today if you haven't already, and to try to integrate them in your apps or your sites, and tell us what you think. And here are the links again for those that want to take note of them. I'll give you a minute or two for that, or a few seconds. So again, ak.ms/webpush for the webpush tutorial, and if you want to fork it on GitHub. And there's also the SW demo for all of the iterative steps we did for taking advantage of the caches and the fetches. And you can reach out to us on Twitter at msedgedev, or you can link up with me on GitHub at aliams. Oh, this slide they didn't replace, so it's all good. You guys can go on your app and the MS Events app and just review the session, please. I hear that they're giving like $2 for Gorilla coding, so that's really awesome for each review you guys do. So please do that. It's a really amazing opportunity for you guys to give. So with that, thank you very much for hearing about service workers. I appreciate your time.